Okay, the last video dealt with three formulas that we use to determine distance, and then use that for determining other variables like velocity, acceleration, or final velocity, initial velocity, all that. Very useful information. It gives us a lot of options as to how to solve a problem. In fact, the beauty of physics is that oftentimes we can get answers from different angles. We can use any number of formulas, and it just gives us that option. Again, the power of algebra allows us to do a lot of different things with a lot of different formulas. We don't have to memorize them all. We can just manipulate our variables in such a way. But I'm going to come up with a couple more formulas for you in this particular lesson. First of all, let's go back to the distance formula that we had, the last one, which is the acceleration of a moving object. And that is that d equals VIT equals 1/2 AT squared. But imagine that the initial velocity is at rest. Well, it turns out if you know the acceleration, you can figure out the distance pretty easily, because if the initial velocity is 0, that 0 goes right there, that knocks that whole thing out, and look what you're left with. D equals 1/2 AT squared. So that becomes now a new formula for us to use for an accelerating object at rest. And here's an example. An object at rest accelerates at a rate of 6.25 meters per second squared for 12 seconds. How far does it travel, and what is its velocity at the end of the 12 seconds? So there's two different problems we can solve with this thing. So let's take a look at this. Result. In dealing with the distance, we plug in the values for 1/2 AT squared. So 1/2, acceleration is 6.25 meters per second squared. The time is 12.0 seconds squared. That's supposed to be uppercase. I forgot to do that one. You punch that into your calculator and it spits out 450 meters. This will be fixed by the time you get it. So now let's calculate the resultant velocity. Well, velocity, since can be obtained by using the formula A equals delta V over T, where delta V means VF minus VI. So we plug in 6.25 for this. We solve for delta V here, and our time is 12.0 seconds. So we multiply both sides by 12 seconds, and that multiply both sides here by 12 seconds, and we get delta V by itself, and 12 times 6.25 is 75.0 meters per second. And we said that delta V is VF minus VI, so we know that VI is 0, so the 0 drops out, and we're left with 75 meters per second as the final velocity. Had that been 10 meters per second to start at, then we would have to add 10 to the 75 to get the 85. Pretty simple. Just algebra and a little plug and play for good reason. Another variation from the previous lesson involves the non-accelerating formula for distance, d equals vt. But now we're going to put a little twist in it. Suppose, however, the object is accelerating at a constant rate. Let's look at the graphical analysis of this scenario. Okay? So, let's do that. So again, we're going to have our little time and velocity graph here. And so the x-axis is time, and this is the velocity here. And let's see, it doesn't say any particular velocity we're starting at here. Starts at rest and goes to 22.2 meters per second. Okay? Well, we haven't done that problem, so we're just trying to figure out the formula with a new concept. Okay, so I have my graph here. I'm going to make t my x-axis and velocity my y-axis, and we've got the vehicle going from 10 to 30. So let's suppose that we have a car going 10 meters per second, and in that time we know that the distance, which is the velocity times the time, and that's going to be 10 meters per second times 6 seconds. So the total distance for this rectangle here is 60 meters. And let's also suppose that it's traveling at 30 meters per second. So that includes this whole rectangle right here. Okay, So in this case, we've got d equals v times t, and that's going to equal to 30 meters per second times 6 seconds, which is 180 meters. But we know that this is going to be split in half, so it's just going to be an average between the two, because it's not staying at the same constant velocity. So in effect then, it's going to split that in half, like it was a right triangle. And so the sum of this, which was 240 meters, now gets split in half to become 120 meters at which the cars traveled. Now, let's suppose that instead of doing that, I just took the average of the two velocities, 10 meters per second and 30 meters per second. And I have a new rectangle right here, where now you have 20 meters per second times the 6 seconds, and now you have 120 meters. So what you're looking at here then is the average velocity of the two velocities. So the average distance that the two would take at their own respective speeds, it gets cut in half because it's not a constant of one or the other, it's a combination of both. So the formula we're going to be using for that is going to be d equals v average times time. So, how far will an object go if it starts at rest and goes 22.2 meters per second in 4.50 seconds? And what is the acceleration? Okay, so the first thing we have to do is figure out the average velocity. When it starts at rest, it's going to be 0, and it ends up at 22.2, so you add those two together, divide by 2, and your average velocity is 11.1 meters per second. So we plug that in right there. The distance now is going to be 11.1 meters per second times the time, which is 4.5 seconds, and that gives us 50.0 meters. Okay? So, and finding the acceleration then, that's the delta v over t, not the average. There's a difference. The average is going to be divided by 2 because you have a beginning point and end point, divided by 2. But for the acceleration, the formula is delta v over t. That's the change in velocity. So that means you're subtracting instead of adding and dividing. So it's 22 minus 0, which is 22.0 meters per second, divided by 4.5 seconds, and the acceleration of that object can be calculated as 4.89 meters per second squared. All kinds of formulas, all kinds of scenarios. In fact, we can come up with even more formulas if we wanted to. But I suggest strongly that you deal with the basics and be able to manipulate with your great algebraic skills that most of you have, and come up with your expanded toolbox by adding those two formulas in there as well, and use them in determining your practice problems. Good luck.